Hi students, welcome to chemistry classes. Today we are going to start with the next concepts in electrochemistry. They are first one fuel cells and second one corrosion. These two are the very important concepts in electrochemistry. They may ask for 2 marks questions in a theory annual examination, and they are also important for your competitive examinations. So first one, fuel cells. Students, here fuel cells nothing but they are more advantageous than the ordinary batteries. And the fuel cells, it was first developed by Sir William Grew using platinum electrodes and hydrogen and oxygen gases. It was first developed by Sir William Grew using platinum electrode and hydrogen and oxygen gases. And the main definition for these fuel cells, the cell or device that converts heat of combustions obtained by burning gases like hydrogen, methanol and carbon monoxide, etc. directly into electrical energy. So here the definition for fuel cells. The cells produce electrical energy by the combustion of fuels like hydrogen, methane, methanol are called fuel cells. So student, here fuel cells are more advantageous than the ordinary batteries. I already told you. Like there are some points as compared to batteries, the fuel cells are more advantageous. Some points are, fuel cells are high efficiency in for example fuel cells H2O2, nothing but hydrogen oxygen fuel cells. So hydrogen oxygen fuel cells, they are more advantageous. They are advantages of fuel cells are, first one, high efficiency. Fuel cells, they are high efficiency as compared to ordinary batteries, and they can be used continuously. Fuel cells can be used continuously, and there is no need of replace of electrodes. There is no need of replace of electrode. It is also a advantages of fuel cells. So student, first advantage of fuel cells are, first one, high efficiency, and second one, we can use it continuously, and there is no need to replace electrodes. And next one, they don't cause pollution problems. They don't cause pollution problems and silent operations. And its efficiency is 100%. Theoretically, fuel cells efficiency is 100%. And students, here fuel cells, example hydrogen, oxygen fuel cells, and diagrammatic representation of hydrogen oxygen fuel cell. This is the diagrammatic representation of hydrogen oxygen fuel cells. Here there are two inlets, H2 and O2, and by using this H2 and O2 there is a generation of water vapor, H2O. So here H2 is bubbled through electrolyte at anode. It undergo oxidation. So student, here hydrogen gas H2 is bubbled through electrolyte. ಇಲ್ಲಿ ಎರಡು ಎಲೆಕ್ಟ್ರೋಲೈಟ್ ನಾವು ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಒಂದು H2 ಇನ್ನೊಂದು O2, and porous graphite rods act as a electrodes. Here carbon rods acts as a electrodes. ಇಲ್ಲಿ ಕಾರ್ಬನ್ ರಾಡ್ಸ್ಗಳು ಅವು ಎಲೆಕ್ಟ್ರೋಡ್ಸ್ ಆಗಿ ಆ್ಯಕ್ಟ್ ಆಗ್ತವೆ, ಆ್ಯಂಡ್ ದೇ ಆರ್ ಕೋಟೆಡ್ ವಿತ್ ಪ್ಲಾಟಿನಮ್ ಆ್ಯಂಡ್ ಸಿಲ್ವರ್ ಆರ್ ಕ್ಯಾಲ್ಸಿಯಂ ಆಕ್ಸೈಡ್. Okay, and they are also act as a catalyst. Student, here ಇಲ್ಲೇನಂದರೆ ಕಾರ್ಬನ್ ರಾಡ್ಸ್ನ ನಾವು ಎಲೆಕ್ಟ್ರೋಡ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ, ಹಾಗೆ ಆ ಎಲೆಕ್ಟ್ರೋಡ್ನ ಪ್ಲಾಟಿನಮ್, ಸಿಲ್ವರ್ ಆ್ಯಂಡ್ ಕ್ಯಾಲ್ಸಿಯಂ ಆಕ್ಸೈಡಿಂದ ನಾವೇನು ಕೋಟ್ ಮಾಡಿರ್ತೀವಿ. ಸೊ ಇಲ್ಲಿ ಪ್ಲಾಟಿನಮ್ ಮತ್ತು ಸಿಲ್ವರ್ ಆ್ಯಂಡ್ ಕ್ಯಾಲ್ಸಿಯಂ ಆಕ್ಸೈಡು ಕೆಟಲಿಸ್ಟ್ ಆಗಿ ಆ್ಯಕ್ಟ್ ಆಗ್ತದೆ. ಓಕೆ, ಸೊ ಫಸ್ಟ್ ಪಾಯಿಂಟ್, hydrogen is bubbled through electrolyte at anode, it undergo oxidation. And second one, oxygen O2, second inlet O2. O2 is bubbled through electrolyte at a cathode. It undergo reduction. It is also a type of a galvanic cell. That is why here cathode is a positive and anode is a negative. Okay, student. Here O2 is bubbled through electrolyte. It considered as a cathode, and in cathode it undergo reduction. And one more point about electrodes. Here porous carbon rods acts as electrolytes, and they are coated with platinum and calcium oxide and silver, and they are also acts as a catalyst. And next one, electrolytes is used in this fuel cell is electrolyte NaOH, sodium hydroxide. Sodium hydroxide is the electrolyte used in hydrogen oxygen fuel cell, and also you can use KOH, potassium hydroxide. And this H2O2 fuel cells, it is used in thermal power plant. Okay, in thermal power plant, chemical energy of fossil fuels is converted into water, and it converted into steam, and that steam is passes through turbine, and that turbine produces electricity. And also this thermal power plant that directly converts electricity, but their efficiency is very less, and more pollution, and it creates more pollution. So this is a simple trick. Thermal power plant, it produces chemical energy of fossil fuels, and that chemical energy of fossil fuels produces water, and water is converted into steam. That steam is passes through turbine, and the turbine, it produces electricity. And the next one, hydrogen oxygen fuel cell. So some of the important points about the hydrogen oxygen fuel cells, like in a diagram. Hydrogen oxygen fuel cell consists of porous carbon electrodes. Finally divided platinum or palladium metals are incorporated into the electrodes as a catalyst for increasing the rate of electrode potential. ನಾನು ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೀನಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ನಿಮಗೆ, ಹೈಡ್ರೋಜನ್ ಆಕ್ಸಿಜನ್ ಫ್ಯೂಲ್ ಸೆಲ್ದಲ್ಲಿ ಕಾರ್ಬನ್ ಎಲೆಕ್ಟ್ರೋಡ್ನ ಯೂಸ್ ಮಾಡಿರ್ತೀವಿ. ಆ ಕಾರ್ಬನ್ ಎಲೆಕ್ಟ್ರೋಡ್ಗೆ ನಾವು ಪ್ಲಾಟಿನಮ್, ಸಿಲ್ವರ್, ಪೆಲಾಡಿಯಮ್ ಮತ್ತು ಕ್ಯಾಲ್ಶಿಯಂ ಆಕ್ಸೈಡ್ನ ನಾವು ಏನು ಮಾಡಿರ್ತೀವಿ, ಕೋಟ್ ಮಾಡಿರ್ತೀವಿ. ಯಾಕೆ ಕೋಟ್ ಮಾಡಿರ್ತೀವಿ ಅಂದರೆ ಅಲ್ಲಿ ಪ್ಲಾಟಿನಮ್, ಸಿಲ್ವರ್ ಆ್ಯಂಡ್ ಕ್ಯಾಲ್ಶಿಯಂ ಆಕ್ಸೈಡು ಕ್ಯಾಟಲಿಸ್ಟ್ ಆಗಿ ಆ್ಯಕ್ಟ್ ಆಗ್ತದೆ. ಸೊ ಹಿಯರ್ that catalyst is used for increasing the rate of electrode potential. And one more point, hydrogen oxygen gases are bubbled through the porous electrodes into concentrated aqueous solution of sodium or potassium hydroxide, which is act as electrolyte. Yes, here sodium hydroxide or potassium hydroxides are act as a electrolyte, and H2 hydrogen gas is bubbled through electrolyte. In anode, it undergo oxidation, and O2 gas is bubbled through electrolyte, and at cathode it undergo reduction. Okay, we can easily write like this also. Hydrogen oxygen gases are bubbled through the porous electrodes like cathode and anode into concentrated aqueous solution of sodium or potassium hydroxide, which acts as electrolyte. So this is about diagrammatic representations and their explanation of hydrogen oxygen fuel cells. And the main reaction takes place in a H2O2 fuel cell. So this is the cell reaction in a H2O2 fuel cells. Anode. So commonly you know, in anode oxidation reaction takes place, in cathode reduction reaction takes place. Cell reaction. Electrode reactions are given below. First one, anode. In anode, H2, 2H2 gaseous plus 4OH minus. 4OH minus is from the electrolyte. H2, 2H2 plus 4OH minus. It gives rise to 4H2O, and it loses 4 electron because in anode oxidation reaction takes place. And second reaction, cathode reaction. Cathode O2 means oxygen gases plus 2H2O, water, and it gains 4 electron, and it become 4OH minus. Again I will repeat it. Second reaction, that is cathode. O2 plus 2H2O, it gains 4 electron, means here reduction reaction takes place. The products in cathode is 4OH minus. And the total net reaction or overall reaction is, here just we should remove 4 electron and 4OH minus, 4OH minus. And the remaining is 2H2 plus O2, and you will get a 2H2O plus O2. It gives rise to 2H2O. So student, here 2H2O and 4H2O, they cancel each other and 2H2O is remaining. 2H2 plus O2, 2H2O plus O2, it gives rise to 2H2O. So this is the cell reaction of hydrogen oxygen fuel cells. And advantages of fuel cells. Advantages like I already told you, that is they can be used continuously, and there is no need of replace of electrodes, and they don't cause air pollution problems, and silent operation, and 100% efficiency, and one more, like 100% efficiency means high efficiency. So let us discuss one by one advantages of fuel cells. First one, the cell runs continuously as long as the reactants are supplied. The cell runs continuously as long as the reactants are supplied. And the second point of advantage of fuel cell, its rate can be controlled by controlling the rate of supply of fuels. Its rate can be controlled by controlling the rate of supply of fuels. And next one, it can be started and stopped anytime and anywhere when required. It can be started and stopped anytime and anywhere when required. And next one, it has a very high efficiency. Advantage of fuel cell, one more advantage is, that is, it has a very high efficiency. And next one, its efficiency can be increased using new electrodes material, better catalyst, and electrolytes. So these are the advantages of fuel cell. And one more advantages, that is the most important advantage, is that it is a pollution free. Fuel cells, the most important advantage is it is a pollution free. And application of fuel cells. What are the application of fuel cells? First one, H2O2 fuel cell, it was used for producing electricity in Apollo space programs. And fuel cells are being used in automobiles on experimental basis. And so this is about application of fuel cells and advantages of fuel cells and a diagrammatic representation of fuel cells. Next one more important concept, that is corrosion. So student, corrosion means the natural tendency of a conversion of metal into its mineral compound on interaction with the environment, like polluted air, water, or other associated metals. It is known as corrosion commonly. So example for corrosion, iron converts itself into its oxide, and one more, copper converts itself into its carbonate, and one more, silver converts itself into its sulfide. So here, corrosion of iron by conversion into iron oxide is known as rusting. So one more point here, rusting means corrosion of iron by conversion into iron oxide. It is known as rusting. And here student, tarnishing, one more important word, tarnishing. So tarnishing means corrosion of silver by conversion into its sulfide. Simply, silver, it converts into its sulfide. It is known as tarnishing. So this is the definition for corrosion. The process of coating of surfaces of metallic objects with oxides or other salts of the metal is called corrosion. Example, rusting of iron and tarnishing of silver. Tarnishing of silver objects. and development of green coating on a copper or a bronze. So these are the example of corrosions. And one more, disadvantages of corrosion. Disadvantages of corrosion. So, and one more point here, in corrosion a metal is oxidized by loss of electron to oxygen and form a metal oxide. In corrosionದಲ್ಲಿ ಮೆಟಲ್ ಆಕ್ಸಿಡೈಸ್ಡ್ ಆಗಿ, ಅಂದರೆ ಆಕ್ಸಿಡೈಸ್ ಅಂದರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಲಾಸ್ ಆಗ್ತದೆ ಅಲ್ಲಿ, ಆ್ಯಂಡ್ ಇಟ್ ಫಾರ್ಮ್ಸ್ ಅ ಮೆಟಲ್ ಆಕ್ಸೈಡ್. ಆ್ಯಂಡ್ ಕರೋಷನ್ ಆಫ್ ಐರನ್ ವಿಚ್ ಇಸ್ ಕಾಮನ್ಲಿ ನೋನ್ ಆಸ್ ರಸ್ಟಿಂಗ್, ಇಟ್ ಆಕರ್ಸ್ ಇನ್ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ ವಾಟರ್ ಆ್ಯಂಡ್ ಆಕ್ಸಿಜನ್. ಸೊ ಕರೋಷನ್ ಆಗಬೇಕಾದ್ರೆ ಅಲ್ಲಿ ಐರನ್ oxide occurs in the presence of water and oxygen. First one, disadvantage of corrosion. The first one, disadvantage of corrosion is formation of unstable coating on the surface destroys the metal objects. Formation of unstable coating on the surface destroys the metal objects. Second point, that is disadvantage of corrosion. It causes enormous damage to the objects made of metal, especially iron objects. And main important, that is a mechanism of corrosion. Corrosion is an electrochemical phenomenon. In corrosion, metal is oxidized by loss of electron to oxygen of air, forming oxide. This is why corrosion occurs in presence of water and air. Example, in rusting of iron, the reaction takes place. The reaction is, this is the reaction of mechanism of corrosion. Cell reaction, 2Fe plus O2 plus 4H plus, it gives rise to 2Fe2 plus, and it releases 2H2O, water vapors. Here ferrous ions are further oxidized by atmospheric oxygen to ferric ion. Means here 4Fe2 plus react with oxygen, that is O2 plus 4H plus, it gives rise to 4Fe3 plus and 2H2O. And ferric ions form hydrated ferric oxide and produce H plus ion. Here ferric ions, nothing but 2Fe3 plus, forms hydrated ferric oxide. The last reaction, 2Fe3 plus XH2O, it gives rise to hydrated ferric oxide complex, that is Fe2O3 XH2O, and it produces 6H plus ions. And last point, prevention of corrosion. How to prevent the corrosion? Some of the important points are there to prevent the corrosion. So actually here the main principle underlying the methods of prevention of corrosion is to separate the metal or isolate the metal from the environment. So there are so many methods are there, like painting and galvanization, nothing but alloying, and prevents as far as possible the contact of the metal surface with a good electrical conducting media, and covering by some chemicals like bisphenol, and cover the surface by other metals like tin and zinc that are inert. And one more, sacrificial electrodes of another metals like magnesium, zinc, etc. So first one, prevention of corrosion. First point, it can be prevented by preventing the surface of metal object to come in contact with the atmosphere. Second one, by covering the metal surface by other metals that are either inert or react with the atmosphere and save the object. And next one, sacrificial protection. Sacrificial protection means here sacrificial electrodes of another metals like magnesium, zinc, which corrodes itself but save the object. So this is about H2O2 fuel cell and corrosion.